enough time to cut and paste as many silly pictures off of Google as I really wanted to. So this talk is therefore not up to my standards, and I apologize for that. So this talks about science and Christianity. At one point we were talking about science and religion, but the fact is I don't study religion. I don't know, I'm not really qualified to talk about it. So the reason I suppose for this talk is, hi, I'm Dr. Dong, and thank you. I'm Dr. Dong, and I'm a scientist. I have my PhD in physics, and I am a Christian. And maybe more to the point, as you might not know, of the variety that is variously described as fundamentalist or evangelical, or whatever you call it. Basically means a Christian who believes in the Bible, as opposed to just going to church. There's a difference, right? In this America, you can believe whatever you want and call yourself whatever you want, and many people do. But I'm that kind, right? The kind they make fun of in the news media. So that's why this comes up, because a lot of people want to know how it works together. So I should give a disclaimer: I do not speak for anyone, really, when it comes down to it. This is just my own thoughts on the issue, on some of the issues. I don't think, do you guys do this well, friend? It's pretty awesome. I don't think I could, necessarily convince people of Christianity. I just don't think it actually works that way. But I do hope to convince you of a few things that I think are important, that will at least push you. These are things I think that we can actually reasonably come to an agreement on, though maybe you will disagree with some of them. So here's the question, right? The question is, what's the relationship between science and Christianity? Can they be reconciled, including this branch or the sort that's fundamentalist? Or really, what we're saying is, can you be a scientist and a Christian? Because some people say no, by the way. I just was given a book, actually. Someone had gotten it for free and didn't know what to do with it. It's by Lisa Randall, who taught at my old school. And she's a real big name in physics now. And she wrote a book during which part of it, she basically makes the contention that scientists cannot be a Christian. I personally find that a little bit insulting, because I don't think her science is all that great anyway. But anyway, whatever. She's welcome to her opinion, but here's mine. So I'm going to make 5 contentions. Here they are as a preview. Okay? I'm going to argue these 5. And so I'm not necessarily going to convince anyone necessarily to be a Christian, but I think I might convince you to see some things differently in some of the issues regarding science and religion. We'll see. All right, let's start with number 1. Number 1 I think is important, is that religion matters. The reason I bring this up is because it is common for people to say, hey, why do we worry about such and such and such? Because it doesn't really matter. Oh, as long as we all just get along, and right? That kind of statement. Why do we make such a big deal? If only the Islamist fundamentalists in the Middle East would stop caring so much about it, right? Then everything would be fine. In fact, some people would say religion is the source of all the conflict. You think of the Crusades or something, right? So that's what's there, and I'm here to make the contention that no, it matters. It makes a difference. It actually matters. The reason is, the reason is partly depends on your definition. So let me start with definitions. You're supposed to do that. I was a debater, so you start with definitions. So religion here's my definition, okay? It's not from a dictionary, I made it up. I think it's a set of beliefs that includes, roughly speaking, where we come from, where we're going, and what should we do in between. Right? Sound fair? So where we come from, that's origins. Now, that's where you believe things came from, right? And where we're going, you can guess where that is, right? That could be questions of heaven and hell or non-existence or whatever, right? And then everything in between is ethics, morality. What should we do now? Right? I think between those cover the major aspects of religion. You agree with that, right? Okay, so if that's the meaning of religion, that's what religion is. The reason is because just because it's called religion doesn't mean it has to use the word God. I think some people kind of slant the playing field sometimes by defining it that way. But here we go. Here are some statements. The question is this one a religious statement? This is not class. You can disagree with me. All right, God exists. What do you think? Religious?
Yes.
Yeah, okay. Yeah, probably. Okay, so I would qualify that as a religious statement. God does not exist. Religious statement?
Yes.
Well, yes, for the same reason, right? You have to, if you qualify this one, you have to qualify this one. Otherwise, it's really very unfair, right? So, all right, so the Bible is the ultimate source of authority. You should call that a religious statement?
Yes.
Yeah, me too. So, no book or person is the ultimate source of authority. Would that be a religious statement?
Yes.
Tim thinks no. Why not, Tim? Or are you just being contrary?
Well, I'm just kind of, that's kind of what there's nothing about a religious text.
You're right. It doesn't. Well, there is something about religious text in its statement that there is no religious text, right? Which I think is still a statement. I would say if this were not a religious statement, it would be very unfair. For example, if you're talking separation of church and state, right? That's the First Amendment, right? And that means it would be illegal for me to teach this, but okay for me to teach this. Now, that seems pretty unfair, don't you think? So if we're going to have a fair definition of religion, then I think we have to characterize both positive and negative statements about it as even ones that don't explicitly use the words like God, but still have the impact of negating other statements about God, should qualify as religious statements. All right, let's take some harder ones. All right, let's see. Because I believe in the Bible forbids homosexuality, I oppose gay marriage. What do you think, religious?
Yes.
Good, okay. This would be an ethics question, right? So that's a religious one. Okay, now, here we go. Because I believe there is no absolute moral system, thus people should be able to do whatever they believe is right, I support gay marriage.
Yes.
Is that a religious statement?
Yes.
No, I think so. No, that's good. I just want to know what other people do.
That's it.
What do you think? I think that under the definition I'm using, which some people use different definitions, and that's okay, right? But under the definition I'm using, I think, again, for an argument of fairness, if nothing else, you have to say that is a religious statement. Why? Because what makes it religious? This part. I believe there is no absolute moral system, right? That statement, right, which is a statement of morality or ethics, right, and that governs ethics, and therefore is itself a religious statement, even though it's a statement against the traditional religions. So I would say that has to be a religious statement. Okay, here we go. This is probably the most common one, because all that really matters is that people are happy. I support gay marriage. What do you think?
No.
It's interesting because it says, it says all that really matters is that people are happy. Is that an ethical statement? It is, because it says what is important in this life, what is important that we should do, a guiding principle for our actions, is that people be happy. Therefore, it's a statement of ethics, and under my definition, I would categorize it as a religious statement. So you see how religion matters. It is very difficult to talk about this topic without bringing religion into it. It's doable. You talk about it in terms of policy, for example. You talk about politics or demographics. Those are generally not really religious statements. But whenever you get into the realm of what things should be or what matters, you end up making a statement about ethics, and therefore you make a statement that is religious in that sense. Okay? So, that was contention one. You know what, before I go on, let me bring up an argument. I forgot to put it up here. All religions are not the same. Anyone who says that is someone who doesn't know anything about the religions. Okay? They are totally not the same. They explicitly contradict each other sometimes. Like really explicitly. Like to say, the other religion, that one's wrong. Okay? Like they are not all the same. The people who do so are usually appealing to a wishful thinking. Well, everyone should just get along. The religions are all really the same. What they really mean is, why don't you all just believe what I do and everything's going to be fine? But it doesn't work that way. The religions are not all the same. Okay? If you read the Quran, and you read the Bible, and you read the, I can't pronounce it, it's like the Bhagavad Gita, right? I can't say it. Or if you read, you read even semi-religious texts, like, I don't know, Analects of Confucius or something, which isn't really religious but talks about God in it. You will find different things. They disagree with each other. They don't all say. And when people say, well, really, X religion is just a religion of love, I find that not personally, I just think that is a very insulting thing to the other religions. The religion of love that they're getting from, that's Christianity. Okay? Christianity talks a lot about love. The New Testament talks a lot about love. Old Testament, the Jewish Bible, not that much. The Quran, not very much at all. Buddhist texts? Not very much. Okay, this whole religion of love thing is taking other things and trying to make them like Christianity. Very insulting, right? Why don't you just try and learn about what the religion actually says, rather than trying to impose what we think about it, right? So I want to say, it does make a difference. You can believe different things. And it is a free country, and that's a wonderful thing, but just because we have the right to believe different things doesn't mean that everyone's right. Just as in this country you have the right to answer your physics test wrong, right? As many of you exercise frequently, see you tomorrow, Tim. But just because you have that, it's your right, no one arrests you, but that doesn't mean you're correct. So that's why I say it matters. It makes a difference in our choices and in how we act, and of course, ultimately, very much so as well. All right, here's number 2. Science is not a religion. I think this should be clear, but I think this one's probably the least controversial. But I want to bring up a few points about the implications of that statement. So what is science? Blah, blah, blah. You know this part. Take an MSI, right? So, it's a method. The key is, right, that it's a method. We call it a method. So we say it's a method for gathering data, right? And for sharing it, right? And so, as you know, it generally includes a hypothesis, you have some experimentation, you collect data, analyze it, present it, right? That's scientific method. You know that. Okay, so I'm not going to belabor that point for you. Now, here's what it's not have, right? You probably know this as well from MSI. It is not a collection of facts. Science doesn't have facts as such because they keep changing, right? The laws of science, as we like to call them, they change over time. We understand things better and we change them, right? So there's no collection of facts. Science is a method, right? It's not a series of guiding principles for the same reason. It's not a description of the universe. What are those? It's not a mathematical framework either. What are those things? Those are, they're what they say, right? Those are maybe philosophical constructs or something, right? They're descriptions, they're ideas, but the science is the experimentation and the data analysis, right? That's the science part of it. The science addresses everything else here, but these things are not science. Fair enough? Okay, so it doesn't have, see, I really would have liked a funny picture here, but I just didn't have time. I apologize for that. It doesn't have a sacred text, right? We should know that from science, right? If you have a sacred text of science, the closest thing you get is the universe. You generally assume that what happens, that's right. That's the only authority you have in science, right? It doesn't have priests, and this is very important because that's very important, right? Scientists are not priests. They are not the people who interpret or pass things down to the masses, right? Because if they were, then science would be a religion. We just said it's not. Okay? It doesn't have rituals, right? You might say, oh, well, what about calculating the p-value? No, that's not a ritual. See, you do that or not as you want. Okay? You don't actually have to calculate the p-value. Though, if you're in my class, you have to calculate the p-value. Okay, but in general, it's not like a rule. P-values are a relatively new thing in science. 150 years ago, no one did p-values. They were more or less discovered in 1915 or so. Okay? Clearly not a part of science necessary. And it doesn't have a creed, and that's very important as well. You cannot say all scientists must believe in X. Because whatever X is, I can find you someone with a PhD who disagrees with it. And I am pretty sure I can follow through on that statement. I can't actually think of any disagreements. Maybe you can find something really ridiculous, but any kind of halfway reasonable thing, you'll find people with PhDs who disagree with it. Okay, so it doesn't have a creed. That's the whole point, right? That you don't have to go to seminary to become a scientist. When you're doing MSI, doing your experiment, you are a scientist because you are doing science, right? No vestments needed, right? You don't have to be ordained a scientist. Okay, so here's contention 3. This is a tricky one. Okay, here's the argument. The argument is, if science takes on the trappings of religion, you know what trappings means, right? The accoutrements, what's a short word for this? The exterior features of religion, right? Then you don't properly refer to it as science. That's my argument. Okay? And a corollary of this is going to be a lot of things that we refer to as science are not actually science. And in fact are closer to a religion. Okay, here's an example. You guys should know this one. In the absence of friction or air resistance, all objects fall at a constant acceleration on the Earth's surface. Right? Please say you remember this, right? Do you remember what the acceleration is? 9.81 meters per second squared. Good. All right. Don't forget the units, right? Okay, good. So we have this statement here, right? True statement? Well, let's say this. Scientific statement? Sure seems like it, right? Hang on. If you think about it, it's not stated as hypothesis, it's stated as fact. So it's not a hypothetical statement, a hypothesis statement as in science. It's not definitively established by experiment. You may, what do you mean, Dr. Dong? You can drop two. No. It says all objects. The only way you can establish this by experiment is what? To drop all objects. That would take a long time. Right? So it can't be, you could drop some objects and see that they work and assume it works for the rest. But you can't actually try it with all objects. Right? Right? So it's not a directly experimental verified fact, and there's no reference to data in it. So in what regard is it a scientific statement? I wouldn't call it particularly religious, but I wouldn't call it particularly scientific. See, we're used to it. This is part of our corpus of what we're used to calling science. But actually, this is something that's a little bit outside of science. Science is a method. People using that scientific method came up with this hypothesis. Now we teach it to you as fact. So, I would say in the end, not a scientific statement. All right, so what is a scientific statement? That's fair. Maybe I'm just being nitpicky, right? Let me give you some examples of things that I think would qualify as scientific statements. Here's one. Galileo theorized that all objects follow the same acceleration as their surface. Why is it scientific?
It says theorized.
Good. It mentions hypothesis, right? We know that's part of the scientific method, so that must be a scientific statement. Okay, so that's a fair one. We measured that objects with a mass ranging between 0.1 and 50 kilograms fell into vacuum with acceleration deviating from one another by less than 0.1 meter per second squared. Go ahead, Ted.
It's just giving data.
Yeah, it is describing analyzed data, right? And drawing no further conclusions from it. That is a scientific statement, right? Okay, good. And this one, our data are statistically consistent with the hypothesis that objects fall with the same acceleration on the Earth's surface. Why?
It says that we did this and it's consistent with a hypothesis.
Right. It just says it's consistent with the hypothesis. It doesn't say the hypothesis must be true, because you don't know that. So you say it's consistent with it. It doesn't contradict the hypothesis, which is usually as much as you can say as a scientist. Either it contradicts it or it doesn't, and that's as much as you can say. Right? Remember the whole null hypothesis, reject, fail to reject, right? You get it. So these, I would say, are scientific statements. And by the way, if you'll notice, these statements are the ones that you'll find in scientific papers, MSI papers, for example, SIR papers. In the previous slide, you will not find statements like that. Statements of truth. Yes?
On the physics classroom website, no.
The physics classroom website is doing its job, but frankly, it's in the strict sense, it's not teaching science.
They're teaching us religion.
I don't know if I'd go that far, because I'm not sure if there's anything. You could argue that it's teaching religion. Frankly, it's just teaching you facts. Not even facts, it's teaching you theories, a lot of theories. They don't bother saying that they're theories, they call them facts. For the record, they're pretty good theories, they work pretty well. But you know, they might stop working tomorrow. Imagine if you wake up tomorrow and F equals ma squared. Now what are you going to do? So, especially if you got a test tomorrow, then you're really in trouble. Okay, so, doesn't this restrictive definition that I've given make it very hard for science to say anything? Yes. So, well, wait a minute. Can't scientists say, things that are important? Well, I mean, the science part of it is doing the data collection, right? After that is a separate step, not part of the science, which is the drawing of conclusions from it, right? That step can go different directions. Let me give you an example from real life, okay? From my life. This is my physics thesis, my PhD thesis, okay? So here it goes. We were looking for this thing called single top, okay? Single top, were you in that? Was that your year?
Yep.
Yeah, all right, good. So I can tell you all about it, or all about calorimeters. Do you do calorimeters?
Yeah,
I think you
it's
did.
still got a video.
Yeah. Okay, so we were looking at we were looking at single top, okay? That's what we wanted to find. Then, in physics, you guys know the whole 95 or 5% thing, p-value thing, right? Okay, in physics we laugh at that. 5% p-value? Yeah, that means that you could have gotten it by luck 5% of the time. That means 1 in 20 experiments is wrong. You realize that? 1 in 20 published results is wrong, just by luck. I mean, even if they did everything perfectly. That's what a 5% p-value means, right? That's a 5% chance that you're wrong. Okay, so in physics we laugh at that. We don't go with a 5% p-value. Our p-value usually uses 5 sigma. 5 sigma corresponds to a p-value of 3 times 10 to the negative 7th. Meaning you have a 1 in 10 million chance that you're wrong. Okay? That's what we call certain. Okay, the odds of you getting it wrong are 1 in 10 million, just to be safe. That's how we do things in physics. Alright, so here's the story. I was working on something, okay? I was working on a measurement of single top, which had never been measured before. So because it had never been measured before, the first question is, does it even happen? Right? Okay, the thing is, everyone believes it. There's no theory that doesn't have the single top interaction. Of course it happens. But still, you have to establish it with a p-value, right? So here's the thing. Physics is a lot of luck in it. All science is, really, okay? There's a lot of luck involved. It's quantum mechanics. Things fluctuate at random. You can't control it. So we do our best. We expected, okay, that we should be able to get 5 sigma if we were lucky with the data. But we weren't, so we got 4.3 sigma. Now 4.3 sigma corresponds to a p-value of roughly 1 in 10 to the negative 6th. 4.3, sorry, 1 to the negative 5th, about 1 to the negative 5th. Okay, so that's a 1 in 100,000 chance that we got it wrong. Okay, so here's the thing. We just came up with this result. Okay, we see 4.3 sigma as our p-value. It's below the threshold that everyone says is what you're supposed to get. Now the question is, so does single top exist or not? And that's what people would ask us. Okay, so tell me, does it exist or not? Right? And we say, well, it depends on what you think is good enough, right? Because if you say, well, of course, everyone knows it exists. There's not a single theory that doesn't have single top in it. Then you say, all right, then, 3 sigma is good enough, right? You have 4.3 sigma, that's plenty, no problem. Or you might be really skeptical and say, no, I need to see 5 sigma. Or heck, you could be extra skeptical and say, heck, I need to see 7 sigma. Like, why not, right? There's no rule. In fact, frankly, if someone is supersymmetry, you guys heard of that? That's like a thing, okay? People are searching for it. Probably doesn't exist. But anyway, if someone claimed to discover it, I would want to see more than 5 sigma because I know just how much physics experiments can screw up. I would need more than 5 sigma, okay? I would want to see at least 7, and I frankly like to see it from 2 different experiments. Right? Because these things are matter. So the question is, does it exist? It doesn't exist. The answer is, that's not my job to tell you, okay? You decide. Is 4.3 sigma good enough for you? I don't know. You decide, right? I'm not going to tell you. I came to that exasperated conclusion after fielding a lot of these questions. So does it exist or not? Well, the answer is, you have to tell me. That's how science works. So science does up to the p-value, but the decision about that p-value, someone has to make that decision, and that is not science because different people, both scientists, can come to different reasonable conclusions based on the same data. Okay? So that's why I want to separate these two. So, if you claim that science says something definitively, right, then you're running into a problem. People say that. Science says, we know from science, right? Usually, it totally has nothing to do with scientific method. You do it like this. See, your mom says, eat more vitamin C, it's good for you. But if you're writing a paper for wellness, then you say, thanks to modern nutritional science, we know that vitamin C is good for your body. There's no actual difference in those two sentences, right? But one of them uses the word science. And you're like, oh, science says so, so we better listen to science. Listen to the way the newscasters on the news use the word science. It's kind of fun, actually. Okay? You basically drop the word whatever you want people to believe what you're saying. Okay? And so, that's funny. I thought I had another slide there. I guess I didn't. Okay. So that's the basic point. People use the word science to be a lot of things, but the things that are more religion than science, those should not be qualified as science, right? To say science says this, that's like a pronouncement from on high, a creed, right? That is not part of science. right? Or, worst of all, I am a scientist, and I tell you this, and you must believe me. That is the work of a priest, and not a good one, frankly, right? That's a priesthood of science. You know, the fact is, people are people, okay? We like being in control of other people. It's fun. Why do you think I'm a teacher, right? I hold your grades in my hand, and you can do nothing about it. So, anyway, don't tell my bosses that part. So, but the point is, people like doing that. Okay, scientists are people too. So, everyone kind of likes to be in control sometimes, right? And everyone kind of likes it. Don't you like it? Maybe you get it here, maybe you get it home, when your friends are like, I don't understand that, and can you tell me more about it? And you say something like, oh, wow. You say something else like, wow. Heck, I do this all the time, right? That's what mod phys is like, right? Totally is, right? Okay, everyone likes to be a priest sometimes, is the fact, right? Everyone likes to be in control of the masses and to be able to hand down pronouncements to them, right? I want to say literally everyone, but plenty of people. So scientists are no different. Some scientists just like to play the priest. They like to be like, I'm the scientist, I'm the expert, listen to me, you humble masses, right? Kiss my ring, right? This is a human thing. I don't particularly fault them. But you have to realize, sometimes scientists get carried away. They say things that are not scientific and try to use their standing as a scientist to get a buy-in. All right, I do it too, right? That's what I do for a living. So, here's my next one. This one I think is kind of interesting. I argue that science derives its power, its social power. In other words, the power it has in our society, the reason people listen when you say science, right? That it derives that power from technology. Which, you know the difference between science and technology? What's the difference?
Science is an object.
Say lower.
Science is method, technology is an object.
Good. And technology is an object designed to, or not have to be an object as such, but as a problem solution, right? You build something. I don't mean just computers, all technology. A pencil is very advanced technology, right? And it was built to solve a particular problem, serve a particular purpose. That's technology. Science is learning how the world works through this method, right? It's that methodology. Okay, so they're not the same thing. They're related, of course. They're not the same thing. You can do technology without science, if you're lucky. So, STEM education, right? Here we go. Science, technology, engineering, math. Changing the world one problem at a time. That's us, right? Woo, go IMSA. Why? Why not arts? Why not English, literature, history, the study of linguistics, and ceramics? Aside from the fact that it doesn't spell anything. Go ahead.
Because those subjects can help increase technology and advanced technology.
That's correct. Because they don't change technology. Look, let's face it. You study literature, people may enjoy reading what you wrote, but it's not going to solve any concrete physical problem, generally speaking, right? So, you can make a nice pot, and that's cool, and you certainly employ a lot of technology to do that. You can even argue that is an act of technology, but it's not going to help starving children in Africa, right? So, I guess you could give it to them and put water in it or something. So, the point is, explicitly, if you read the documents about why STEM education is important, they do not talk about the fundamental understanding of the universe. They say it's going to help our economy. Why? Because it makes technology. When you make technology, people buy it. See? Yeah, read the documents. That's what they say. That's what they talk about. I'm not a big fan of them, but if you read, that's what they say. Technology drives things. Here's why. These are Maxwell's equations. They govern electromagnetism. Okay, they're very complicated. Aren't they scary? Yeah. You remember, so you just took the AP? Sorry, that hit a, you did a test.
I'm taking it tomorrow.
Oh, you're taking it tomorrow, okay. Do you Maxwell's equations learn? Oh, you must. You must have Ampere's law, maybe?
Yeah.
So, for those of you who are interested, this is differential form, so you probably don't recognize it, but this is Gauss's law, that's Faraday's law, and Ampere's law.
No.
Collectively, they form Maxwell's equation. Okay, great. I'm not going to talk anymore about Maxwell's equations, relax. But here's the thing. Suppose I say, Maxwell's equations are awesome, you should totally believe in Maxwell's equations. Like, you might say, why should I believe Maxwell's equations? Let me give you a convincing argument. Because I use them to build your iPhone. Maxwell's equations were instrumental in the design and construction of your iPhone. And you say, oh, wow, I wouldn't be able to build an iPhone. They're like crazy, right? Oh, so you can actually build one with that? Yeah. So I'm like, if you use Maxwell equations, then you could build one too, in principle, right? Not in reality, they're very complicated. But here's more to the point. If they were true, your iPhone would not work, right? Your iPhone was, I mean, okay, sometimes it doesn't work anyway, I understand that. But none of them would work if Maxwell's equations weren't true. So why do you believe Maxwell's equations? Because you've got a gadget in your pocket that uses Maxwell's equations, like a big chunk of Maxwell's equations right there, right? Not to mention every computer and every piece of circuitry ever made is all Maxwell's equations all over it. Without Maxwell's equations, you would not get anywhere on this. So, and those of you who are going to study electrical engineering, by the way, get used to those guys. Okay, so this is what I'm saying. Why do people believe in science? Because it gives you technology. So it's like, if we didn't have it, then you wouldn't have technology. Oh, I believe that, right? So let's try a different argument, a tougher one. Oh, sorry, that's the conclusion, right? Okay, now let's try a different one. Why should I believe in the Higgs boson? I'm a particle physicist. Given the evidence, I believe in the Higgs boson. So why should you? Well, it's a little trickier. They didn't use it to build your iPhone. I said, well, okay, I studied it using science, and science is the same thing that they used to find Maxwell equations, but those were used for your iPhone, right? So it's like the same thing, it's like right by association, right? It's true it doesn't actually affect you, but I use the same methodology that we use to make your iPhone, okay? So like, okay, what does that mean? And I'm like, okay, look, we do a lot of experiments. Maxwell did a lot of experiments too, right? And Maxwell's equations work out, and so we think ours work out too, because we did a lot of experiments. That's the methodology. A little bit weaker, right? And the guy's like, so does Higgs bosons make my iPhones work? And you're like, no. But maybe in the future we could use this discovery to make cooler discoveries later, cooler phones later, right? Because like, the CRT, which is the cathode ray tube, which dominated, until flat screens came out in the 90s, they dominated, all screens were cathode ray tubes. And those were discovered in the 1890s. The television didn't come out until the 1930s. It took 40 years to make it happen. So, you can make that argument. Well, maybe we can use these later. And people say, well, I don't know, what's the conclusion of this argument? Meh. Okay, right? It's not quite as strong an argument because you can't honestly connect it directly to any piece of thing that affects you now. But you can say, well, it's the same kind of methodology, right? A little bit weaker. All right, here's a fun one. All right, you guys heard of Pangea? Right? That all constants used to be connected together. Why should I believe that all the constants used to be connected together? This is tougher to connect to an iPhone. I can say, well, I studied it with science, and science is the same methodology which gives Maxwell's equations, right? The same argument, right? And you're like, okay, you studied it with science, so an astute observer might ask, you did experiments? Right? How do you do experiments on continental drift? Especially continental drift that happened in the past. Like you build a planet and see what happens, right? Like what did you do experimentally? And so the answer is, when it comes down to it, no. Okay, not really, but what we did do, we totally used a lot of math, like lots of math, okay? And Maxwell's equations are also lots of math, so it's probably science too, right? Okay, I'm obviously paraphrasing that argument, but the guy is like, okay, so suppose you were wrong, and the Earth just spontaneously appeared last week. Would my iPhone still work? What's the answer?
Maybe.
Probably.
Maxwell.
Well, assuming Maxwell was still working, and this might be the answer, right? Well, yes, but you should believe me because I use science, right? And the answer to that, of course, is right, because it's a little bit tougher of a connection to draw if you think about it. Now, the good news is, or the bad news, depending on how you look at it, is that most people don't ask all those questions in between. Most people don't ask experiment. Some people say, as part of the reason for this kind of thing, some people say there is no experiment, there's no scientific proof of God. And I'm like, scientific proof? Like, what kind of experiment would you do? Like, what would be your control sample for God? Really? Like, what could you be scientific? You can't do an experiment on that, right? And so, when people like to use the word, right, it sounds better when you say it. So I'm hoping at least, even if you don't agree with everything I say, to call that awareness, give you some awareness over the use of that word. It shows up a lot in our society. In fact, the reason people believe science is because it works, okay? Because we say, I have this thing, and it's a cheap cell phone, I got it for free, right? And it is not a smartphone, it is a dumb phone. It actually really has severe developmental problems, okay? I'm not allowed to use the other word, right? So, severe developmental problems here. But despite all that, it still weighs like 50 grams, it fits in the palm of my hand, and with it I can communicate with a 1 second delay, which I complain about, with anyone in the world, right? This is a good argument for science, because you're like, this comes from science, and I'm like, oh wow, I believe science, right? But the fact is, not everything that we call science actually has anything to do with the technology. For example, then we keep doing that. We used to call it government, you know.
May I have your attention, please? Ron Johnny Sundar, please report to the 1506 RC's office. Ron Johnny Sundar to the 1506 RC's office.
Great then. Used to be called government, now it's called political science. What changed? The name, nothing else. Why? Because they wanted to use the word science. Is there anything scientific about political science? Come on, how can you do an experiment on countries? Do you like make your own and see what happens, like a Lord of the Flies thing or something? Like, generally speaking, it's not experimental. How could you call that a science? But they do, because they want to. Marketing, to be fair, that is much more experimental, but it sounds better, doesn't it? When you